First off, the square root of -1 is the same thing as I, but another way to look at that is anytime there's a negative under an even root, you're going to take it out front as a negative, or excuse me, as an I, and then also to know that I squared is equal to -1. So anytime you have I squared, you're going to replace it with -1. Like our previous examples, the very first thing you have to do is get the negative out from underneath the root before you apply any other root rules. So right here, my -2 underneath the square root, that needs to come out. And when that comes out, it comes out as an I. So just emphasizing that goes first. Then another square root rule we have is when you multiply two roots together, then you multiply their radicands. So in other words, 2 times 18. Now if I multiply 2 times 18, I get 36. And if you're lucky, the square root in front of you is a perfect square, so you don't have to break it down. The square root of 36 is 6. So square root of 36 is 6, so we have I multiplied by 6. But formatting, we put the i's in the back. So instead of 6, I times 6, I put 6i. Okay, so here's another one. Again, we've got to make sure that we address these negatives underneath the root first. They come out as an I. So this becomes I times root 15 multiplied by I root 3. Now 4 different things multiplied together, I times root 15 times I times root 3. You can multiply in any order you want. So I times I is I squared. Square root of 15 multiplied by the square root of 3 is the square root of 45. I squared is equal to -1, so I'm going to replace the I squared with -1. Now we need to simplify the square root of 45, and the square root of 45 is 3 times 15, and the 15 is 3 times 5. So 45 is 3 times 3 times 5. And we know to simplify a root, if you have 2 of a kind, you get to take one of those numbers out. So I notice I have a pair of 3's, so I'm going to take a 3 out front. There's still a 5 trapped under there. So I have -1 out front, a 3 out front, and a 5 under the root. And so I end up with -3 root 5. You can maybe see here why taking care of the negatives first is important, because if we applied the rule like root 15 times root 3 to get to root 45, if we would have done that right away, we would have had -15 times -3 and had the square root of 45 and no I squared out front. So take those negatives out front first. This one here is pretty quick. I notice that I have the negative underneath, and I have the negative underneath. So the I comes out. I can multiply in any order I want. So I times I is I squared. I don't really need to multiply these two together like I did with 15 and 3 because they're perfect squares. So the square root of 64 is just 8. The square root of 144 is 12. And 8 times 12 is 96. I squared gets replaced with -1. So -1 times 96 is -96. Okay, last example, but instead of with multiplication, we're looking at a little bit of division. One more time, the key is let's get the negatives out from under the root first. So this -81, that negative there, I'm going to take the I out, the negative comes out as an I, I have the square root of 81, and then in the denominator I have the square root of 3. There's a ton of ways that you could proceed from here because the square root of 81 is 9, but ultimately our goal when it comes to fractions and roots, We don't want to have any roots in the denominator. So if I decided to make that 9i over root 3, I'd have to multiply top and bottom by root 3 to get rid of the root 3. A shortcut that we sometimes use to simplify a little quicker, and I'm just emphasizing here that I can take, let me just do this really quick, this I, I'm going to go ahead and move that off to the side there, because I over 1, I times root 81 is back here, and 1 times root 3 is back here, so I can put the I out to the front, because that's times I over 1. And then, once I have that, I have a couple extra steps here, let me just delete that. Okay, so then I'm putting root 81 over root 3 as root 81 over 3 using that rule. Putting them underneath the square root is a simplifying technique, and 81 divided by 3 is just 27. Now I can go ahead and simplify this one. 27 is 3 times 3 times 3, and then I have a pair of 3, so I'm going to take a 3 out front. So I have 3i root 3. I want the I in the back for formatting, a plus bi for complex numbers. So 3 root 3i is my final answer. Okay, again, if you wanted to, I'm just going to quickly write this. It won't look very nice, but if I went from here, I could make this 9i over the square root of 3 pretty quickly. And if I go that route, I would multiply the top and bottom by the square root of 3, and then that would give me 9 root 3i over 3. 9 times root 3 times I, root 3 times root 3 is 3. Then these cancel, 9 and 3 cancel, and I get 3. And then I end up with the same answer, 3 root 3i. So there's quite a few different strategies, but putting a root over a root, putting those under one root is a good way to get rid of a root in the denominator.